In this clip, we're going to turn to the second type of stoichiometry. Remember that I mentioned that stoichiometry is the study of ratios of elements to each other in compounds, but it's also the study of ratios of compounds to each other in reactions. And we're about to look then at the ratio of compounds to each other in reactions. And it turns out that an extremely useful concept in studying these ratio compounds to each other in reactions is the concept of mole reactions. And I'll explain this concept right now. And the reaction we're going to look at for the rest of this lecture is the following one. It's a classic inorganic reaction, 3H2SO4. H2SO4 is sulfuric acid. Reacts with 2 aluminum hydroxides. And they react to make aluminum sulfate. Plus water. And put into chat whether you think this reaction is balanced or unbalanced. Take your time, look at all the elements. Yeah, there are 12 H's on the left, 12 H's on the right. This is balanced. And since we're looking at the ratios of compounds to each other in reactions, we're going to want balanced reactions. Okay. So, for this reaction, a reaction is a recipe. 3 sulfuric acid molecules are required to react with 2 aluminum hydroxide molecules. So if I have 3 H2SO4 molecules, that would be enough. 3 H2SO4 molecules would be enough to run how many times the reaction? Well, the reaction asks for 3, so you can run the reaction. Runs the reaction. RxN will be what reaction? One time. So let's try another question. 3 dozen H2SO4 molecules. Runs the reaction how many dozen times? So I don't write the number yet. 3 dozen H2SO4 molecules run the reaction how many dozen times? Put it in chat. Well, if 3 molecules run the reaction 1 time, then 3 dozen runs it 1 dozen times. And notice it's just the same number. 1 time, 1 dozen time, and now we get to a chemical thing. Let's choose another color. How about green? 3 moles of H2SO4 molecules. Runs the reaction. I leave it blank. how many moles of times? Put that in chat. Remember, a mole is just the same concept as a dozen. So 3 dozen H2SO4 molecules runs the reaction 1 dozen times. Put it in chat. 3 moles of H2SO4 molecules runs the reaction how many times? Yeah, it runs it 1 mole of times. And when you run it 1 mole of times, that's what we call the mole reaction. So it's 1 mole reaction. It runs the reaction 1 mole of times. So let's compare. Let's try another green one. 2 moles of AlOH3 run the reaction how many moles of times? Put that in chat, please. Notice that to get the reaction to run, you need 2 AlOH3 molecules to run at once. So 2 moles of it will run it how many times? Put it in chat. 1 mole of times. And so what's the number of mole reactions that 2 moles of AlOH3 can run the reaction? Put it in chat. Well, if you could, each time you run it 1 mole of times, that's 1 mole reaction. So 3 moles of H2SO4 can run the reaction 1 mole reaction times, and 2 moles of AlOH3 can run at 1 mole reaction times. And this respects the ratio of the coefficients in the periodic table. And now let me get to start introducing you to the very important limiting reactant problem. Let's say we started off with just 1 mole of H2SO4 and 1 mole of AlOH3. 3 moles runs 1 mole reaction times for H2SO4. Put in chat, what would the mole reactions possible be? What would be the possible mole reactions for 1 mole of H2SO4? Put that in chat. Remember, 3 moles are required for 1 mole reactions for H2SO4. So 1 mole of H2SO4 would be how many mole reactions? Put it in chat, please. And put it in chat. Yeah, it would run it 1/3. It's exactly a third of the number of mole reactions is 1/3 mole reactions because it's 1/3 as much H2SO4. And 1 mole of AlOH3 could run how many mole reactions? Remember, you take 2 moles for 1 mole reactions for AlOH3. So 1 mole of AlOH3 is what fraction of 2 moles? And therefore, how many mole reactions could I run with AlOH3 with just 1 mole of AlOH3? Put it in chat, please. And the answer is you can do 1/2 mole reactions. So with 1 mole of H2SO4 and 1 mole of AlOH3, each different reactant can run the reaction a different number of moles or times. And if we had 1 mole of each, which compound would I run out of first? If I had 1 mole of H2SO4 and 1 mole of AlOH3, which compound would I run out of first? Put it in chat, please. And look at the number of mole reactions, because mole reactions is the number of times you can run the reaction. So 1/3 mole reaction is a smaller number. This is smaller. And this is bigger. And therefore, I will run out of H2SO4 first. Runs out first. And this is therefore called the limiting reactant.